Welcome back to Let's Code Java. I am Alex, a senior Java developer. Today we are going to do something that might seem like an overkill at first glance. We are moving away from a simple script to a full-scale service architecture. Our goal is to make our code truly robust, building a dedicated service layer to isolate our business logic, implementing a custom exception hierarchy to handle every dangerous spot in user input, and ensuring that our shape creation flow is completely protected. By the end of this video, you will see how much code it takes to build a perfect system. And more importantly, we will discuss when this level of engineering is actually necessary and when it's better to keep things simple. Let's code Java. So we start with our third step as professional exception handling from console. And first of all, we need to find our dangerous spot and to build roadmap how we will implement this issue in our code. So I created the small roadmap and I identified three places, three dangerous places. They are reading shape type. When we read shape type, user can provide text. So we make sure that this text is one of our known shapes. Shape dimensions. When we ask user to read dimensions of our shape, it can also be provided as a number, positive, negative, or any letter or string. So we need to deal with this. And the last thing is the shape creation. We need to control the shape creation and make sure that when it's created, its properties are valid. So let's read it fully. We need to read shape type, one of circle, rectangle, and square. And if user input not one of above or shortcuts, print informative message like unsupported shape type, use circle, rectangle, or square only. It's important that message will be informative, so when user receive it, it can understand its mistake and to fix it immediately. Shape dimensions. For circle, we read radius. For rectangle, we read width and height. And for square, we read side. And if user input invalid, we just print the same message. If it's not a number, we print illegal input provide positive integer. If it's negative integer or zero, the same illegal input provide positive integer. Because user see what the input was, he can fix it immediately. And the last thing, shape creation. We want to make control of shape creation flow in a way that only shapes with positive integer dimensions can be created. If parameters are illegal, allow to user fix their mistakes by providing user-friendly error description. We can create this in a while loop until until it's fixed. So to do so, we create some classes. Let's start with exceptions. We create custom exception classes that will hold our custom messages. We defined our base class as geometry exception. It's abstract, so we don't want to create any instances of it. And it extends, inherits Java runtime exception class. It's base class of exceptions. And it has its constructor with message that with simple validation that if message is empty, it just print geometry exception or message otherwise. Wrong shape exception will deal with the illegal shape usage. So, so when shape is wrong, we want to provide user with the available shape. So its constructor will receive available shape. It's allowed to have constructor with available shapes only if input is empty, or it can receive shape and available shape. So it will prepare some message and the available shape with it. So prepare message will just print the shape with with this and uh, and uh, and print wrong shape exception shape name like wrong shape exception circle and or CR something that it's not valid. And available shapes message will call use one of the following shapes with list of available shapes like circle, rectangle, or square, like this here. This is one of our exceptions. Another one is the legal dimension exception. It's a very simple class. It's used basic class with string message to override the super, and also it's has the simple no args constructor with just say illegal value, please provide positive integer. It's from here. Okay. Okay, so these are our messages that we will use when input is wrong. Now let's start from the actual end with shape creation. Make control of shape creation flow in a way that only shapes with positive integer dimension can be created. If parameters are illegal, allow the user fix their mistakes by providing user-friendly error description. So let's start with our shapes and we make some changes. First of all, we add the builder class. We have abstract static shape builder class. It has two dimensions, the same dimensions as a shape has, and these members are private. So in order to set them, I need to call these two methods, dim1 and dim2. And in these two methods, I check the whenever it's negative or not. If it's not positive, I just throw the illegal dimension exception that we just seen. Otherwise, I save the value. The same I can do for dimension 2, like this. And because these are private, in order to set them, I need to go through these methods only. So in this way, I know exactly that in my shape builder, dimension 1, dimension 2 has only positive numbers. Planar shape, and I have, so for usage, I need to expose getters for them, get dimension 1, get dimension 2, and that's it. Let's see how we use it in our classes and why it's inside the planner shape class itself. And because it's inside the class, the word static edit. So let's take a look on our circle builder. So first of all, our circle constructor is private. That means that nobody except this class can create instances of this circle. So it cannot create it with any radius. And our circle builder, it's extend shape builder, it's implement the build that returns circle, and it's expose method radius with radius that call actually super dim1 radius. So that will ensure that our radius is the positive with the getter. So this is our circle builder. This is how we control that our circle radius will be positive. Rectangle, the same way we extend our shape builder. We define our width and height methods with calling dim1 and dim2 method of our super shape builder. And our build just return rectangle with the again dimension 1, dimension 2 from the super. Let's finish implementing of our square class. So we want to add public square builder side that will receive inside, call super, and return this. Same way as previous ones. And our planar shape build will return square with this one. So in this way, in square also constructor is private, and in rectangle also constructor is private. So in this way, the only way to create our shapes is only through the different builders, and different builders make sure that width and height are positive. Okay, now we want to read them from the console. In our calculator, okay, we want to read them from the let's go back to our file. So shape creation, make control of shape creation flow in a way that only shapes with positive integer dimensions can be created. Check, we do it. And if parameters are illegal, allow to user fix their mistakes by providing user-friendly error description. We will work on it now. So let's see our console builder hierarchy when we actually read data from the console. Console shape builder. So we have our console shape builder. We have scanner, instance of scanner class that's actually can read from the console. We have abstract, protected abstract method init builder that all builders will implement. And we have implemented method build. So method build will have a while loop with init, and init will be true only if builder will be succeeded. Init builder will be succeeded. It's init builder will be succeeded. That means it's not throw an exception. So in that case, our parameters are valid and we can proceed, and we return builder.build that will return the planar shape in case of it's not null. If builder is not null, it's trinary operator. That means that if a condition is true, we do this one, and if it's false, do it this one. It's just a simpler way to write if-else statement. So this is our build, and we have helper class read shape dimension with a prompt that we print our prompt. We read input as a string, try to parse it as integer, and if it's failed, we just throw our illegal dimension exception. So it will get here and print message and try another dimension. So let's see how we implement it. Console circle builder here. The implementation here is very simple. A builder here is just circle builder, we know it. So we create instance of circle builder, and we call read shape dimension with prompt enter radius, and it will return our radius. And we set radius with builder.radius radius. That's it. Constructor with scanner just called the super. Our rectangle builder, the same way, it has its constructor and it creates rectangle builder. Here we have, because our methods return this, in this way, we can write the initiate in all init construction in this flow as single line, builder dot width super rich shape dimension enter width will return the builder itself. So you can call height, and it will uh, it will read the height dimension. It also will return itself already initialized with width and height. So we can return builder like this. It's just a way of writing. It's more easy to read it than a regular way. For builders, sometimes we use this way if we return this instance. So let's implement our square builder the same way. We just created square builder new square builder, and we can return builder side reshape enter side, and here and sorry, square builder like this, and that's okay. So let's go back to our file here. Let's check the shape creation issue. If parameter make control of shape creation flow in a way that only shapes with positive integer dimensions can be created checked, we do it. using builders only, and if parameters are illegal, allow the user to fix their mistake by providing user-friendly error description. We also did it by providing this prompt enter site and the main build logics is using the while loop with init flag, and init flag will be true only with the init builder will not throw exception, and it throw exception only if input is invalid. So we will be here in this while loop until the input value will be valid, and we prompt user with the legal with the valid message. So they know how to fix it. So we check also, make it check, shape creations also checked. Now, shape dimensions, read shape dimensions, circle radius checked, rectangle width and height check, square side check. If user input invalid, print messages, it's not number, illegal input, provide positive integer, and if it is negative, integer or zero, illegal input, provide positive integer. Also check, we done it. And shape type, read shape type. This one we must provide. Now let's take a look on our console shape builder service. So this class with actually create in charge of creating our shapes. So one of its helper class will be read shape that will return shape type. So the same construct here while true there. Please provide shape, one of shapes. We read the shape. We try to parse it from shape type from string. In this case, if we have some exception, we throw illegal argument exception or wrong shape exception. We can also do it like this. So it will be the same exception because we catch only this exception here, and we will print error message, and we will be in loop until we can construct valid shape type from here. So let's go to our class here, read shape type, one of circle, rectangle, square checked. And if user input not one of above a shortcut, print informative message like unsupported shape type, users use circle, rectangle, or square. Let's make sure that it's done like this. Please provide what is wrong shape message. Wrong shape message. Use one of the following shape with available shape types. So it's also check. So in this way, we fixed all our issues, all our dangerous spots, and what is left is to put all things together. So I show you also in calculator, we don't have a lot of changes, the same calculator as previous one with a constructor and support shape, if it's shape and shape type, and won't change here. We added shape not supported exception there, and we use it in inherit classes like this. In calculate area, we try to check if shape is supported and is instance of our shape, in this case a circle, and another one we just throw exception here. So if we will receive shape from wrong type, we throw exception that will be printed that the shape not fit. We do so in this one, in rectangular one, shape not supported exception, and in square calculator also. So this is a change. And we also created our area calculator service. This just will have two methods, get calculator according to planar shape. If it's null, we throw wrong shape exception. If shape type is null, we also throw wrong shape exception with shape type is null. And if it's not, we just create our calculator for circle, circle, square, square, rectangle, rectangle. And then we have method calculate area. The public method, this is private method, calculate area that receives shape. We get our calculator here, and we return calculator dot calculate area like this. Because get calculator our private method, in our constellation there is no way that get calculator will return null. It can throw exception or return specific one, so we can safely use here calculator dot calculator area without checking whenever calculator that returned from the method is null or not, because it's our method, our private method. We also can add the if here. It's not the error, but it's not necessary right now because this is the private method, so we don't require to do so. And now a console shape builder. We have constructor that receives scanner and list of variable shapes, and we have also public method called build shape that has two methods, read shape that we just saw that return shape type, and get builder, this one the same, because read shape is our method, private method, so we know exactly that shape won't be null. From here also, it's it's always return something or throw an exception. So we don't need to check. So we specifically don't need to check here whenever it's null or not to use it here. To use it here, we can add null check. Also, it's not a error if shape null null. Throw wrong shape, shape type is null, like this, but we have warning here that condition shape type null is always false. So we just can remove it because as I told you. And then get builder will also return specific builder never null, so we can call builder.build in this case. So we added two services, console shape builder that was in charge with of creating shapes, and area calculator service that will receive shape and find appropriate calculator and calculate our shape. So let's see the main method. Now it's very simple. System out print line. Welcome to the area calculator. We initiate the scanner. We create our console shape builder service with scanner and the variable shape from shape type. So we call build shape from the service and we receive planar shape. We create our area calculator service here and just call calculate area to create area. We receive area. We use number format to print it without points after without print only integer part of the number. So we put the area is format, not format area. Let's see how it's work now. So I run it. Please provide shape. Let's create Alex. So we have wrong shape exception. Alex use one of the following shapes, circle, rectangle, and square, and it's also repeated. So let's give him circle like this. Now radius, let's type again Alex. Illegal value, please provide positive integer. So let's give him minus 14, also illegal value, and if we can have 15, it will work. Okay. The same, let's try it again with the, I don't know, rectangle. Rectangle, it's working, minus 8, warning, so I give him 10 and 10, and I have the 100. So that's why it's work now. Uh, that's it for today. We have written a significant amount of code. Just think about it. Our two builder hierarchies alone consist of 8 classes, as many as all our shapes and calculators combined. And here's the hard truth. Technically, we have not added any features. We spent all of this time just making our code safer. Is complete exception handling always a good idea? Honestly, no. If you are building a prototype or just want to test a quick idea, do not waste your time on complex architectures. Write dirty code, feel the logic, and see if it works. At that stage, deep error handling will only slow you down. However, if you are implementing a feature in an existing long-term project, that is a different story. You need a proper design that aligns with the overall architecture, followed by robust code and exception handling. It takes longer than a quick hack, but it is much faster than doing it twice first, without errors, and then trying to build them on later. In the next video, we are going to take this solid foundation and move it into a real world. We will migrate our project to Spring Boot, introduce dependency injection, and replace our console input with a professional REST API. If you have your own thoughts on when to over-engineer and when to keep it simple, let us talk in the comment below. Also, do not forget to like this video and subscribe to the channel if you're ready to take your Java skills to the enterprise level. My name is Alex. Thank you for watching, and let's code Java.